All right, hello everybody. It's been a few days here since we talked. Last class you were to complete your quiz, your 5 question quiz. Hopefully you've done all that. I've had about less than half of you have done it so far, but you do have until the end of the evening to do so. So hopefully we'll do that. So we spent the last really 4 classes talking about simplifying trig identities, where we wanted to use our trig identities to be able to simplify and get it down to, if we can, one term, no fraction answer, stuff like that. All right, so now we are switching gears a little bit and we're doing what's called verifying a trig identity. Right, so you can see verifying a trig identity right here. Sometimes you may also see the word prove, okay? Prove the trig identity. So proving and verifying are the same thing. Before we get into this lesson, I want to actually go and just show you real quick. Okay. Here's our lessons that we've been doing. There's the first 4 on simplifying. Here's where you're supposed to submit your quiz. Here is the next day. Now, you can't see this yet. It's unpublished, but since I'm screenshotting it, I can show you this here. So let me click on this. And here's what I have just to show you so far. So this worksheet right here is the same worksheet that we've been working on. This is this worksheet that we have here. We're picking up on page 6, as you can see in the bottom right-hand corner. This is called page 6. I have the notes from all the other simplifying stuff we did. So we're going to go through this. There are some other simplifying in here as well, like right here, simplifying. We'll talk about the difference between the two momentarily. But back to the Schoology page. So that's the video of the PDF that we're working on right now. I put 2 videos up here, okay, both on verifying trig identities. This is one that, again, just a video that sort of goes through the process. This is a really good video. Let's double check. I think this is the one. Check real quick. Yeah. All right. So that is Professor Dave. He does a really good job of talking about verifying trig identities. So his video is really good. And then this other video is from a good math website called Purple Math. And this goes through. Now remember, if you can't see this, just hit the arrow and up in the new screen. Okay. This actually has talks again about proving trig identities. As you see, it says page 1 of 3 on the top. And this goes through a good explanation. It gives some examples and shows you what to do. So just keep going. You can go to page 2 and hit more. So this is more of notes. Okay. This is more notes of talking about to do this, or how to do proving or verifying trig identities. So that's what that website is. So take a look at that. So then, back to this. So we have those 2 videos, and then I have 2 other worksheets. Now this first worksheet is nice. This first worksheet, I think it's 12 problems. I think is what it is. But the nice thing is at the end, it has all the work and all the answers. So you can practice these problems and look directly. I'll just show you real quick since we're here. Show you directly verifying ones. So you see here, spaces and boxes to work on everything. So there's 8. Yeah, there's 8 on that page, and then there's I guess 8 more on this page, and then underneath, boom, there's all the answers. Okay. So you can work. There's 16 problems altogether, so you can work on those as far as the practice goes. And then the last PDF that is on this page, I call it worksheet 2. This is another one. This is the one I'm going to actually want you to work on now, as far as practice goes. So this is another really good worksheet. The first couple, again, are simplifying, and there's some other simplifying throughout. But then the second page gets into some verifying. And there's a little challenge problem if you want to challenge yourself. And that's really like the first part of it. And then here's worksheet 2, which is some more verifying with a challenge problem. Here's some review material from the unit circle stuff. You can take a look at those, but they're not really super important in this, but you can take a look at those. Then worksheet 3, again, more verifying with a challenge problem. Again, here's another review. We haven't actually learned how to do these yet, so definitely don't worry about this review. It's on page 6. We did these before in the last section, or last part of the unit circle identity, or unit circle notes. You can work at that if you want to. It's up to you. But then the last page is, last two pages, I apologize, are a review of both simplifying and verifying. So this is the worksheet. And it doesn't hurt to work on the simplifying. Still work on the simplifying because you still need to be able to simplify for our next quiz that we'll have. Not right now. It's going to be obviously in a few weeks here. So, excuse me. So that is the one that you're going to want to work on. Okay, you're going to want to work on the second. Well, actually, work on both of them. But I'm not going to go over these, the first PDF, because that's the answers are all there. But I will be going over these with you. And you don't do all. I'll tell you which ones I want you to do and stuff like that each day. We'll probably spend about 3 to 4 days on verifying as well. Okay. So I just wanted to make you aware of that. But definitely make sure, look through these video links. I'm going to be posting videos from this PDF here. But the other videos are ones that I found that are very good and very helpful. Excuse me, I apologize. I'll explain more things. Like this first video, the guy does a really good job explaining it. So, excuse me, I apologize. So let me go back to our actual lesson. So again, this is the PDF that one more time, at the top right here. We've been working on this one for simplifying. As I said, this is page 6 in this PDF. I don't know if you printed it out or not, but if you don't, you can just go to page 6. But when we verify, I'll tell you right now, the one thing that makes verifying different than simplifying is this right here. It actually has an equal sign in the problem. So the nice thing about verifying trig identities, you know what the answer is supposed to be. You already know it. And the simplifying, we didn't know that like this one was turning into sine squared. But now in verifying, we have two sides. We have a left side and a right side. You know that it's going to have to equal one of those sides. Okay? So it's one thing I like more about verifying. At least you know what the answer is. You just have to work towards it. I think I mentioned before too, like these are going to be more, you'll see, it's going to be a little bit more in depth. These problems may take more steps, but you should really max out at 5 steps. If you get to 5 steps and you don't quite have that answer, unfortunately, you've probably done something wrong. So you need to go back and retry it. So don't get frustrated. Okay. I think you guys handled the first half part of this simplifying pretty well. So don't get frustrated. Okay. Like I said, I like the verifying ones because I know the answer is there. Okay. I know the answer is there. Now, a couple key things to know about when you verify. First of all, if you look up here at the directions, work on each side separately. Okay. Unlike an equation where if I had something that was, x minus 4 equals 5 or whatever, you subtract or add, you add 4 to both sides to get your answer of x equals 9. Okay. You do not do that. Okay. You do not do that when you are verifying trig identities. You work on one side and one side only. You never move something from one side to the other. Okay. Imagine there's like a block there. You can't move something from one side to the other. So that's very, very important. So remember that, please. You can only work on one side. That's what it says in the directions. Work on one side separately. Okay. And as it says here, make sure you don't move things from one side to the other. Okay. Don't do that. You can work on both sides at the same time, but you just can't move things from one side to the other. Okay. Very, very important. Now, doesn't say in the directions, but the one video talks about this. Usually you want to pick the side that looks more challenging. Okay, because it's going to be easier to go from a more challenging side to the easier side than it is the other way around. Because if I start on the right side here, say I start with 1, well, what do I turn 1 into? There's so many things. There's an infinite number of things I could turn 1 into. But on this left-hand side, this is definitely the harder looking side. Okay, this is definitely the harder looking side. So you should be working on the left side for this problem. Okay. So again, only work on one side at a time, never move something from one side to the other, and start with the harder side, okay, of the problem. Sometimes you might not know what the harder side is, but we'll talk about that when we get to those problems. All right, so let's take a look at this problem, number 1, okay? Again, as we said, we're going to be working on the left-hand side. So our usual rules still come into play here, where we want to use our identities. If you notice on the left-hand side, I don't see any squareds. I don't see any 1/overs right now. But if you remember, one of our most important suggestions is to try to turn things into sine and cosine if at all possible. Okay? So here's how I want you to work on this. So we can do sine. I'm going to make it fraction because everything else is going to be a fraction. So the sine of theta over 1, I'm going to drop off the theta. Cotangent, if you remember, is cosine over sine times secant is 1 over cosine. And all of that equals 1. Okay? All of that equals 1. You got to write each step. Again, it's sort of like, again, when you solve an equation, you want to show what's happening the whole time. You don't get rid of stuff. So you got to keep that there. Now, well, you look at what we do. We're basically going to be, if I just look at this left side, we need to simplify it like we've been doing. So we notice here, okay, well, if I'm multiplying, I can cancel things out. Well, doesn't sine and sine cancel out? Doesn't cosine and cosine cancel out? So what are we left with on the left-hand side? We're just left with 1 equals 1. Check. I like to always put a check at the end to show that I have verified this trig identity. So we have proved or verified that the left side equals the right side. It's just like we're doing an equation with regular algebra. It's doing the same thing. You're finding out what x is to make the left side equal the right side. So just real quick again, if I do that problem, x minus 5 equals 4. X minus 4 equals 5. I add 4 to both sides. Cancels out. I get x equals 9. Well, your goal always should be, let's check our answer. Let's just see if that works. If I put 9 in for x, I get 9 equals 5, which, yes, 5 equals 5. Check. There you go. Now, at this stage of your math career that you've had, you don't do that last step where you check it. You do that more mentally. Excuse me. But yeah, you should definitely always check it, and that's what we're doing. The same thing with identities. Okay, we're making the left side equal the right side. Okay, that one's an easy one to start off with. The second one, a little bit more challenging. Okay, a little bit more challenging because when I look at this one, to me, the left side and the right side are about the same. Okay, the left side and the right side are about the same. So this one, it really doesn't matter what side you pick. If I have a problem like that, I like to always try to work with the left side. Okay, so that's what I'm going to do here. I'm going to work with the left side. So again, this is like a game of chess. Like I do verifying a game of chess if you've ever played it before. A good chess player does not plan one move at a time. A good chess player makes moves as they think 2, 3, 4, 5 moves ahead. What's my opponent going to do if I do this? And so forth and so on. So verifying trig identities are a lot of the same idea. Okay, where you want to think about what's ahead, what do we need to do? So if I'm going to work on the left side, I'm going to work on this side right here. Look on the right side. What does the right side actually have? Well, it has a cosine. That's the most important thing. The left side doesn't have a cosine. I need to somehow make this so that I can turn that sine squared into a cosine squared. So when I see my sine squared and cosine squared, I'm definitely thinking about my Pythagorean theorems. Okay, this comes from our main Pythagorean theorem of sine squared plus cosine squared equals 1. Okay, this comes from that. So my idea is I need to solve for cosine. All right, well, again, what if I subtract by cosine squared on both sides? Okay, now I'm not verifying, I'm just using this identity. So what do I get? Sine squared equals 1 minus cosine squared. And we know that. We had that. Oh my gosh, I'm going way back here real quick. We know that from right here. In trig identities, here's the main cosine or the main trig function we started with, but we know it can be rewritten in either one of these two forms here or here. So we know, like I said, we want to turn sine squared into cosine squared. So I'm looking at this one right here. And that's what we just did. If you know that, you don't need to show this work of right here. You don't need to show this work if you already know that. Okay, but I just wanted to remind you that that's how you do that. So what have we done? Okay, we have found that this sine squared right here is going to turn into that 1 minus cosine squared. That's what we know. So in order to do that, everything else is still there, meaning we have 1 minus 2, but now my sine squared here turns into 1 minus cosine squared. And it's very, very important that you put that in parentheses. It's 2 times that. Now, what I like to do, sometimes the videos will show working on both sides. I'm just going to keep this right side like this because that's what I want my answer to turn out to be. Okay, I'm just going to keep that like that. I'm not going to simplify that one either. You don't need to do double the work. The videos, the first video that the guy does, he sort of shows that. But if it's more difficult like this, I wouldn't worry about it. Let's do a little math. Well, all right. I can't do 1 minus 2. That's not the right order of operations. I have to distribute negative 2. That's what I need to do. So I get 1. If I distribute the negative 2 to 1, I get minus 2. Okay. Then if I distribute the negative 2 to negative cosine squared, doesn't that give me plus 2 cosine squared? And again, what is that supposed to equal? It's supposed to equal this. And again, here's your thinking of your chess move. I'm looking at my, oh, great, now I got cosine squareds on both sides, and I had the 2 in front of that. So the only thing I need to simplify is that. What is 1 minus 2? It's negative 1. So I'm just going to rewrite this as 2 cosine squared theta minus 1 equals 2 cosine squared theta minus 1. Check. So we did it. So, once you think about it, it's not that bad. You know what I mean? This is a middle of the road problem. The first one was definitely an easier problem. But, these range, okay? And the hardest part of a lot of these problems is to just get started. So I'm going to do these last couple problems with these factor problems real quick, and then I'm going to stop this first video, and then I'll continue. So our algebra skills, again, are very, very important. Okay, everything we do in algebra, we can do for trig, as far as all of our properties and factoring and multiplying, whatever. So if I look at letter A, I have 2 terms. I have a squared minus a squared b squared. The most common type of factoring is to always use GCF. You always want to check GCF first. Is there a common factor, the greatest common factor, that I can factor out of both terms? And the answer to that would be, yeah, I can factor out an a squared. And when you do that, well, if I factor a squared out of itself, I'm left with 1. And if I factor a squared out of a squared b, I'm just left with b. Now, this is not the trig part where you're like, well, I can't have that answer. That's mine. We're just simplifying this. We're just factoring. And these factoring rules are going to be used in some of our other problems. Okay, so, so GCF is a common factoring. Also, for this one, I don't have 2 terms. I have 3 terms, so I can't do GCF. So I do what I always call reverse FOIL. So I got 3 terms that's squared, so I can do this. So I have an x squared and an x squared. At the end, 1 is only 1 when you get 1. 1 times 1, and with a minus 2, they both need to be minus. So I can factor it to x minus 1 times x minus 1. If I want to simplify that a little bit more, I can do x minus 1 squared. That's just a quick review of some factoring techniques that you can use that we're going to use for some of our other problems that we have down here. Okay? And you'll see that right away in example 4 and in example 5 when we do that. All right, like I said, I'm going to stop this video right now, this first video, and I'll continue with the next video. Thank you.